This is a summary of our problem statement. As I have discussed with you that this is an array, and this is the number of element that I want to rotate in an array. So we have taken an example over here. So we want to rotate the array by 2. So this is the output that I will be getting. So it's a quick summary of our approach. In approach number 1, what we did is like we did a brute force approach, where we take a temporary array, and the size of that temporary array was order of d. For example, in the you can take this as an example where we have taken an array of size 7. We have rotated we want to rotate this array by 2. So what we took is like we took an array, temporary array of size 2. We took the first two values of the array and we rotated the rest of the element like 3, 4, 5, 6, 7. So this is what we got. We didn't iterated the last two element, as we are not supposed to waste our time. And so what we did is like in the next step, we restored the value from temp to the last two position. So our space complexity was order of d and the time complexity was order of n. Note that in worst case, when d will be equal to 9 minus 1, means we want to rotate n minus 1 elements in an array, then in that case the space complexity will be order of n. So our next step was to reduce this space complexity. So in approach number 2, what we did is like we targeted we targeted on reducing the space complexity. So this is what we took an example of an array of size 5. We want to rotate the array by two element. So what we came with an logic is that we will be having a space complexity of order of 1. So what we did, we took a temporary array, a temporary variable, and what we did, we stored the value of the index 0 over there. We rotated the rest of the array and we put it the value of this at the last of the index of an array. Similarly, we did rotation 2. So why we did rotation 1 and 2? Because we want to shift the number of element by 2. So suppose if there were n elements that we want to rotate, so we did n rotations, and in that n rotation we iterated the array by n. So when we were targeting on space complexity, we neglected our time complexity. So here the space complexity is order of 1, but the time complexity is order of d into n. So the next approach is approach number 3, and that is the optimal approach, where what we did is we took a GCD of from the array of size of an array and the number of element that we want to rotate. So what we got was space complexity of order of 1 and the time complexity of order of n. So how did we did was like we broke down the array into different sets. So here we want to rotate the array by two elements. So we broke the array into two different set. We rotated the array for two different set differently. So for example, you can see over here like for 1, 3 and 5 we rotated and we got a result of something like this, and for 2, 4, 6 we rotated something like this and we got the result something like this. So in this way we got our optimal solution, that is space complexity of order of 1 and time complexity of order of n. So here is a brief summary of this. We divided the array into two sets based on the GCD